Well, welcome and hello, and welcome to our engineering webinar. This is the October version of our webinar. I started to say September, but September's already gone away. So we're in October now. So this is our October version of the engineering webinar. Glad to see all of you with us today. Our congenial co-host, John George, is not with us today. He's out somewhere. Not sure exactly where he is. I think he's out doing some ABIP inspections today, so he won't be with us. This program is actually produced by the Alabama Broadcasters Association and its engineering division, and it's brought to you every third Tuesday of each month. So make sure that you put that on your calendar because we have special guests and programs set up each month. We're actually underwritten by our good friends at Max Connect. Max Connect is a full service engineering company, and they do sales and service primarily to radio stations. They have, as they tell me, everything in their warehouse ready to ship from microphones all the way to antennas. And they also have an engineering department that can handle any type of repairs and maintenance, as well as studio and transmitter build out. So make sure that you take an opportunity to check them out there at their website, maxconnect.com. Notice the spelling on that, and my slide is a little off center today, but that's okay. It's Maxxkonnect. So check them out and tell them you appreciate them underwriting our program because that goes a long way. They not only underwrite the cost involved for this webinar, but also our engineering academies that we hold throughout the year and various seminars and other events that we have. One other item is that our special guest that was supposed to be with us today, Mark Johnson, those of you who know Mark, he's the owner of Link Up Communications. Mark has had for a number of years some rather bad back problems, and he went through a series of surgeries just I think about a week ago, and he let me know yesterday that unfortunately he had to be rushed back to the hospital just yesterday because of some more complications with his back. So he asked if he could bow out and not be with us on the call today and reschedule you when he gets to feeling better. I know that he'll appreciate you keeping him in your prayers because Mark has really had a rough time for a number of years with his back. Link Up Communications, which is Mark's company, if you're not familiar with it, Link Up handles satellite distribution for end-to-end program feeds and internet feeds, and a couple of big things that happened just here in the last few weeks or months, I guess it is now. They now have a full supported and teleport based in Denver, Colorado, right outside of Denver, and they can do all kind of satellite distributions through there. And one of the big items that came out in the news just a few weeks ago, Link Up Communication was rewarded with a contract from ABC Radio Networks. They are now the exclusive distributor of all the ABC network activities, all their programming. So that's a real big thing. So check them out as well. Link Up Communications. And see their information. And Mark said he did want to be back with us, and if at all possible today, he might try to join in with us if at all possible. So today it's you just got me, and we'll talk about several items today. I think of extreme importance to engineering. I did want to talk or just share with you some information concerning the national EAS test that we had back at the beginning of the month on October 4th. And the chairmen of all the state emergency communications committees, the SECCs, were on a conference call with the FCC and FEMA following the test, and it appears that everything went really, really well this year. As a matter of fact, we probably had better response than we have with any of the previous tests. In Alabama, I can tell you here, we actually are approaching 98% success. Of the stations in the state actually received and relayed the test. A few that did not get it, some of them had a situation where their unit was back at the factory being repaired. They either had a lightning strike or some technical problem with their equipment, and it was back at the manufacturer being repaired on that particular date. There was a few, and I want to mention this, that still has the old, outdated software in their EAS devices. And I can't stress enough the importance of making sure that you have the correct software in your computer, most up-to-date software, and not only the software, but you also need to have the correct patch, the security certificate patch. And I see Wayne Pasita on the call today, and I sort of joke about the security certificates. I sort of call it governmental password. It actually makes sure that your credentials in your EAS device matches the credentials from FEMA or whoever actually issues a national test or alerts. That way they match up, and that hopefully will keep hackers from getting into your system and issue the wrong types of tests and alerts. So make sure that you've got the correct security patch. Now, I'm sure that everybody on the call today is full aware that there is a new software coming out. Most of the manufacturers either have it ready now or will be, in just a matter of weeks, have the software available. And this new software must be installed on your device by December the 11th of 2023. So don't let that date slip by. Go ahead and I think most of them you can actually go to your favorite vendor or and actually pre-order the software, or go directly to the EAS manufacturer themselves and make sure that you get that software. What this software is, if you're not familiar with it, several years ago, there was a new distribution protocol introduced, and that protocol was called CAP, Common Alerting Protocol. It doesn't take the place of EAS. It's just a different way of distributing using IT and IP data stream. And so one of the features of CAP is that it will allow you to get more information, especially for television. And you also get extremely better quality because it'll be first not relayed from another station if you get it directly off of a CAP. So what the FCC decided to get all the stations and manufacturers to do is that with the new software, if you receive a test or an alert, your unit will pause a few seconds and look to see at the CAP servers that you're monitoring. Look to see if you received it from a legacy source like a local radio station or a TV station or whoever your monitor sources are, the unit will pause, check the CAP servers to see if that same message is available in CAP format, and if so, it will air the CAP version rather than the legacy version. If the particular test or alert that you received from a legacy source is not available in CAP format, then it will continue to air the legacy format of that particular test or alert. This is a great advantage for television stations because with legacy EAS, if you received, for instance, if you received a Amber Alert, your crawl would only show a message that would say a child abduction emergency has occurred. and a listener or viewer at your watching your station, if they are hearing impaired, they won't be able to hear the entire message about the child abduction. But if you receive it in the CAP format, you will get that entire message, which would include the total package that was sent out by the law enforcement agencies, such as where it occurred, how old the child was, what kind of car they were driven, or how, all the message, all the information that's in the message would be available for you to have in your crawl. So that's one reason the FCC it has mandated that everybody update their software so that you'll be able to have that particular feature. There are a few other items in that software that have to do with sort of the names of some of the devices like NPT, the PEP stations, and EAN. These are all changing to a new type of, that will have a different designation. And the reason why they're changing that is so that the public can understand it a little bit better. If they get something that says NPT, they're not really sure what that is. So they're actually changing the nomenclature so that it'll actually be more noticeable and understandable by the public. So that's a couple of things that's coming up. So make sure that you do that. Again, remember that the date to install this new software is going to be December the 11th of 2023. And I have spoken briefly recently with all the manufacturers, and they're all either have their, as I said earlier, they have that software available and fixing to release it, and a couple of them are still working on finishing beta testing. So it should be out. I would imagine by the 1st of November at the latest. So make sure that you get that. It's very easy to upload on all the devices, so it doesn't take but just a few minutes to do, and that way you'll be ready to go. Now, in order to do that, most of the manufacturers indicate that you have to be running the correct current version of the software in that device. You can't take the new version that's coming out that has the CAP information embedded in it and just load it onto your unit if you're running an older version of software. So you have to make sure that you're actually running that at the present time. And speaking of EAS, and we'll just sort of make this an EAS program today, and any of you that want to chime in with questions or comments about it, that'll be good too, since we're sort of winging it. Oh, I see my good friend Paul Burke has joined us on the call as well. So anybody that has any things to share, we'll open up and just open up and we can go with that. Let's talk real briefly for those of you who may not be real aware of how the EAS system is actually set up. And we can actually talk a little bit about the history in the time that we have on the program today. And let's look a little bit about the history of it. And I'm a history buff myself, and I always like to see how things migrated, how it got started and migrated through the system and all. The history of it actually started many years ago, back in 1951, with something called Conelrad. I'm not sure if anybody's on the call as old as I am and remember Conelrad. You probably have to ask somebody over 30 years old what that was. But Conelrad was a system whereby if there was a national alert, all the radio stations, which back then were primarily AM, there were a few FMs out, but primarily AMs, all radio stations had to go off the air. And then selected radio stations would come back on the air, and they were actually using, they would come back on the air either on 640 kilohertz or 1240 kilohertz. And they would broadcast the emergency message, which they received via the AP or United Press teletype. They would broadcast that emergency alert for about a minute, and then after a minute they would go off the air, and then other stations around the country would come back on the air on 640 and 1240, and they would broadcast an emergency message as well. The thinking by the federal government at that time really sort of made sense, and luckily we never had to use it. But their thinking was that avionics back in those days were not as sophisticated as they are today, and the way an enemy pilot would hone into a particular city would be by listening to a particular radio station that they knew was in a particular city. Well, by the situation where different stations would come up on the same frequency, for the first minute, you may have a 640 on the air in Pittsburgh. The next minute, somebody on 640 would be San Francisco. So it was sort of a weird situation. It would hopefully would confuse an enemy aircraft, but that was the way Conrad was actually designed to work. And as I say, luckily we've never had to use that. In '63, we actually got rid of Conrad and we came up with something called EBS, the Emergency Broadcast System. And that was a revolutionary change from Conrad, where you got the messages from someone that you were monitoring. The only disadvantage that I saw in EBS was the way that you notified the station that was monitoring you. You would have to turn your transmitter off for approximately 10 seconds and then turn it back on. And if memory serves me correct, and some of you on the call may remember better than I do, but as memory serves me right, you had to do that twice. You would turn your transmitter off 10 seconds, then back on, and then turn the transmitter off again, and then come back on. That would trigger downstream monitoring that there's an emergency alert fixing to be disseminated. The problem with that was with some stations, if you turned your transmitter off, you couldn't get the transmitter to come back on. So that was sort of a problem. But that was the way the EBS system actually was designed to work. Then in 1997, we developed and came out with a replacement for EBS, and it is the system we are presently using today, and that is the EAS system. This was really was a big step in emergency alerting, especially for program directors, because it was actually designed and still designed so that you can actually pick and choose what type of test that you want to interrupt your programming for. All of you are aware that have set up devices in your EAS devices, that there are a ton of different alerts or tests that you can set up and alerts, and you only select the ones that are, first of all, that are required by the commission, and then any others that you wish to do, you can pick and choose. You particularly, like in Alabama, there would be no need to have a volcano alert or what set up, so you can actually set that up. EBS was one of those that what you see is what you got, and you didn't have a way to pick and choose. But with EAS, that actually gave you the ability to do that. The Common Alerting Protocol that we mentioned a while ago actually came into being around 2011. Again, that did not replace EAS. It was just another distribution protocol called Common Alerting Protocol, and it allowed, initially was set up for FEMA to be able to issue tests and alerts, and now it is actually opened up to all the state EAS committees to actually be able to send information. If they have the technical capability, they can send information in CAP format as well, and that started around 2011. And the test that we had on October the 4th, that was actually sent via FEMA using Common Alerting Protocol. Most devices that are out today allow you to actually program usually 4, 5, or 6 different CAP servers that you can monitor. And that allows you to pick up if your state is issuing tests and alerts, and they're able to send those out with that protocol, then you can set that up in your EAS device, and you get better audio, as we mentioned earlier, and also television stations can get a lot more information. IPAWS, which is a name that's been floating around for several years, the Integrated Public Alert and Warning System. This is part of FEMA, and this is actually how the system that they use using CAP protocol to issue alerts and tests out to individual radio and television stations. Well, what is required at a broadcast station? What, as you as an engineer, what do you need to make sure that you're doing there to comply with FCC regulations? Well, it's pretty simple. First of all, you need to have a device. You need to have one of several devices that are on the market today. Digital Alerting Systems has the DASDAC. You see these primarily at television stations. SAGE Alerting Systems has the SAGE Index. Those you see primarily at radio stations. I think, and this is just my understanding, there was the reason that you see more of the DASDACs at television stations than you do SAGE Index is that the DASDAC initially had a built-in character generator. While the EAS can actually feed data out to your local, your station's character generator, DASDAC actually had one built in. So I believe that may have been part of that. Some of you in TV may have some more information about that. There's a couple of other devices out, Gorman Redlick, which has been around for a good number of years. They have a unit, and they have, when CAP came out, they had an add-on box that would go with this unit. Another unit that looks similar to the Gorman Redlick is a trilithic. Most often you see the trilithic units being used at cable systems. It works very well with the way the cable system operates. Part 11 of the FCC rules, as you know, the Commission has a set of rules and regulations, and they're broken out by parts. The one that we use technically for AM, FM, and television is Part 73. Part 17 deals with towers. Part 94 deals with such things as STLs and microwaves. But Part 11 is what deals with EAS. The rules say that every EAS participant, and everybody is an EAS participant, they're participating national. There was a time back several years ago where you could select not to participate in EAS activity. You would be a non-participant. The only situation about that was that if there was a national or state or local alert, your station actually had to go off the air. You could not stay on the air if you were non-participating. The Commission has since actually deleted the ability to stations to be non-participants. So now everybody is considered a participant. And you have to monitor 2 sources, local sources. This can be your LP1 or LP2. This could be a radio or television or satellite or microwave system. But you have to monitor 2 sources plus the IPAWS network. And these are the things that you need to make sure that you're going through as you set all this up. One, you need to verify the audio quality from the sources that you're monitoring. You have to remember that if there is actually a test, you're going to rebroadcast that over your station. So you want the audio quality to be higher quality as possible. So make sure that the audio that you're picking up from whoever you're monitoring, radio, TV, or satellite, or whatever, make sure that audio quality is good. It doesn't have hum or static or buzz or anything like that. And also the levels are correct. Most of the devices on the market today actually have input meters, bar graphs, where you can actually set the level so that when you actually relay a test, that will not be too low or too high or distorted. One thing I always tell stations to do, and I'm not sure how many stations really do this, but it's important to match the playback level to match the station program level. So you don't want to be having the program running and all of a sudden there's an alert and the audio level is so low you can't hear it, or it's so loud that it knocks you into the next room. So you want to match the playback level on your EAS device to match the level of your program, and that's very easy to do in the modern technology. And here are the operational requirements, and this is I'm sort of preaching to the choir today on this, but I think it's important to review. You're required to receive a weekly test from both of your assigned monitor sources. That could typically be your LP1 and LP2. The word assign means that your state Emergency Communications Committee, or EAS committee, as it was called in the past, actually has a monitor assignment list that you should have a copy of or have access to, that will list all the different zones that your state is divided up into, and it will have who you're supposed to monitor in that particular zone. If you have problems monitoring one of the assignments, then you can actually get a hold of your EAS committee, and they can assign you a different monitor source so that you can continue to get the correct information. And not only do you receive the weekly test from both of these sources, but you should also receive a weekly test through the IPAWS system. The IPAWS system actually sends out a required weekly test each Monday at 11 o'clock local time. There was one sent yesterday for Eastern, Central, Mountain, Pacific, and several other zones. I remember, and I tell this story, you may have heard me tell this story before, but when all of this came out years ago, I actually had units set up on the workbench to make sure that everything was going to work. And they were going to feed the first required weekly test from FEMA on Monday. Well, on Sunday, I heard the alarm go off on the EAS devices, and I said, "No, what the world is that?" And I go in and look, and it's a required weekly test. And I thought to myself, we've already messed up. They're sending it on Sunday instead of Monday. But I looked at the log, and the test was for Guam, which is a U.S. territory, but it was for Guam, and it was already Monday in Guam. So it worked. It worked very well. So you have to receive a weekly test for both sources. Now, you can have more than two if you wish, and a lot of stations do, but you are required to have a minimum of two monitor sources plus IPAWS. You're also required to transmit your own weekly test, and it needs to go out on all stations. And here's an important point. It has to go out not only on your main channel, but on all secondary audio and video streams. What that means is if you are a FM station and you're running digital, then you have to make sure, if you're running a HD2, HD3, HD4, however many multi-streams you're actually sending, you actually have to send that test out on those as well. The same thing is true for television. If you're running a .1 or .2 or .3, and I've seen some stations running all the way up to .8s and .9, regardless of how many streams you're running, that weekly test must be relayed or transmitted on all secondary video streams as well for television stations. So make sure that you set it up. I've run into some stations doing ABIP inspections that their encoder does not have the capability to do that, to actually insert it on all the different streams. So if that is the case, you need to make sure that you invest in an updated encoder that will allow you to do that. Most of it has an input for EAS and GPI input from your EAS device so that it will trigger and actually insert that on all the different streams. You're also supposed to receive and relay the required monthly test, again, on all stations and all secondary audio and video streams, just like the weekly test. It has to be relayed. This is the only test. The weekly test is not required to be relayed, but the monthly test is required to be relayed, and it must be relayed within a 60-minute window. Back when this first came out years ago, that window was set for 15 minutes, which was rather a tight window. And we always tried here in Alabama to run the monthly tests somewhere around 17 after the hour, so that hopefully it would fall during a bottom of the hour break for television stations, which as normal, it never worked that way very well. So the SBE, along with the NAB, petitioned the commission to have that window opened up, and the commission agreed. So they have that window now at 60 minutes. So, and that allows you to hold it off if you desire to. Somewhere in that 60 minutes, you're going to have a break in television and in radio. So you can actually hold it off. If you're doing a newscast at that hour or something, you can hold it off and actually run it, relay it during the actual break. Other requirements is, and this is a no-brainer, you have to receive and relay a national emergency alert notification. That is a message that's actually issued by the federal government from primarily from the White House, and there is no delay on it. It has to go immediately. Again, on all stations, secondary audio and video streams must relay that. One of the things about the regular tests that are sent and regular alerts that are sent that have audio, whether it's text to speech or real audio, there is by commission rules, there's a 2-minute window, a 2-minute length set up, so your message cannot run any longer than 2 minutes. The devices, EAS devices, actually have a hard drive or a way that it actually records those messages, and they're set up to read and write at the same time. So when you get an alert, a normal alert, it will start recording, and approximately 2 seconds later, it'll start playing it back, but it's limited to 2 minutes. This goes for any type of alert that you're doing. However, an EAN, an emergency alert notification from the White House, does not have that 2-minute time limit. As a matter of fact, your EAS device will bypass the recording and go live. Jokingly here, you can't. You don't want to tell the president to quit talking for 2 minutes. You want the message to get out the way it should. So the devices are set up. When it gets an EAN message, it will actually bypass the recording mechanism in your EAS device and actually put that audio live out through your system. And obviously, all this information, any kind of test that you receive, any kind of test that you transmit, any type of alert that you receive, must be entered in the station log. The station log has a place where you keep up with all the different anything that is required by the commission as far as EAS is concerned. It must be entered in what's called the station log. Most of you are aware of the station log. It sort of took the place of what was at one time called the transmitter log, where you had to log meter readings and all, which is not required anymore. A lot of stations still do, and I applaud them for doing it, because it's good to keep a watch on your transmitter to see what it's doing. It's just not required by the commission to maintain a log, but the station log is required. Not only EAS part of the station log, but any major malfunction of the tower lights must be entered into the station log, and also any major outages or component replacements or calibrations of your RF transmitter system. So if you change an exciter or a transmitter or anything like that, you have to put that in the station log. This station log, as most of you know, has to be reviewed weekly by your chief operator. And the chief operator will go down that log and make sure everything is correct and been logged in the log like it's supposed to be. People ask me from time to time, should the engineer be the station log? To quote our good friend Wayne Procida on the call, it depends. It doesn't have to be, but it can be. And in most stations, the chief engineer is the chief operator, but it can be the operations manager or somebody else in the station, but they have to have the information and the knowledge to know what is supposed to be on that particular on the log, to know if it's okay. If you're not the engineer, if it's somebody else, if they see something on that log, then they need to report it to the appropriate department to get it corrected. That is, if you've missed a weekly test from a particular source, or you didn't get the monthly test or something like that, as far as EAS is concerned, you need to check and make sure what the problem is. The first line of defense, I always tell people that if you missed a weekly test from one of your monitor sources, the first thing you do is check your equipment to make sure your equipment's working. I recall going to a station that I was inspecting, and he had missed some weekly tests from a station. We checked his EAS, and there was no audio on it. And we sort of walked around behind the rack to see maybe if a wire had broke off or something like that. And the comical thing was that the radio that he was using to monitor this particular source, the board op, that's back when we had board ops, unplugged the radio and plugged in his cell phone charger. So he didn't have any audio for that particular source. So you need to make sure that you check that weekly log. That's one reason the commission says it has to be checked weekly, because things like that will happen. These logs must be retained for 2 years. You can either keep them there at your station in a file folder somewhere, or you can actually place it on the online public file. The commission was so nice to put a spare empty folder called additional documents on the front page, where you can put things that you don't want to lose. So you can actually put if you wish, you can put the station log there. Real quickly, I wanted to run through, if you are in each state has a committee, and that committee has set up a distribution system to actually relay the messages from the primary entry point, which is where normally the national alerts come into the state. But there's a particular way that you want to go about setting these things up, and I want to take just a few minutes here and walk through this and sort of share with you how we do it here. First, you set up a committee. The state has to have a committee. It's required by FCC rules. The members of the committee, you want people like the State Broadcasters Association involved in it, the State Cable Association, if you have one, the Emergency Management Agency, the National Weather Service, technical representatives in both radio and television operations. You need to have all those available on your committee so you can discuss things and make it set up right. The state normally is divided into zones. EAS zones. This is the way ours is set up here in Alabama. We have 9 different zones, and this is where the LP1s and LP2s come in that we were talking about earlier. The committee will also set up 2 statewide networks. Most all states have set up a statewide, 1 or 2 statewide networks, and their job is to relay messages from the primary entry point station in your state. Most states, obviously, and only have 1. Some states have 2. Typically, they are a 50 kilowatt AM station that may or may not cover the entire state. We only have 1 in Alabama, based in Birmingham. And so we have a state relay network, and you probably have 1 in your state as well. One of our statewide networks is the Alabama Public Television Network, which has 9 transmitters around the state. So as you can see, it pretty much covers the entire state. And they have direct connection to the PEP station there in Birmingham. So they relay that down through through all their transmitters, and the LP1s and LP2s in each one of those zones will be monitoring one of those APT stations. Our second state relay network is the Alabama Public Radio Network. They don't have as many transmitters as the television, but they have 1 in each in the major cities, 1 down in Mobile, in Montgomery, in Birmingham, Florence, and Huntsville area up there. So they do cover the major. They also monitor the PEP station directly, so they get a direct feed. So our LP1s and LP2s in most areas is the Alabama Public Television Network and the Alabama Public Radio Network. Now in your state, it will be something similar, set up that way. We here is sort of a way it's broke down. We use a second a backup system to our state relay network, a satellite system, actually made by and installed by Global Security Systems. It has a entry portal, a secure entry portal, which we don't really have time to go through today, but this allows all designated agencies in the state, such as the law enforcement agencies that issue Amber Alerts, the emergency management agency that issues statewide alerts in various counties and all. They have access to this web portal where they can actually generate an alert. And this is actually a CAP server that it actually generates in CAP format. It goes through an aggregator, which actually goes over the satellite, the GSNet satellite, and then also it's interfaced into IPAWS. So we can send it both on the satellite and the IPAWS, which we normally do. And then it is received by your EAS and goes out to the public. This is our satellite network I mentioned. Several years ago, we decided to have a redundant backup system. Redundancy is really key in this, not only in just regular maintenance of your radio or TV station, but it's also very important in EAS. So at present, we have I think it's around 43 downlinks at stations around the state. And this is another redundant source that we have to transmit and distribute not only state and local alerts, but national alerts as well. You may not have that in your state, but you will have at least 2 statewide networks. And we also have, and I'll mention this just in passing, and if you're interested in this, you can email me or call me on the phone, and I'll be happy to tell you actually how to set it up and make it work. We set up a statewide EAS monitoring system where we are monitoring a number of different stations around the state. As of today, we're actually monitoring 180 different units around the state. One particular manufacturer has a way that you can actually send it to our FTP site. Another manufacturer, we actually have set it up to have an email set up in there that will send to our monitoring system. And then this is sort of a printout of what we get from different stations. This is an old printout, so you don't see many stations on there, but we're getting information or data just like you do on your logs that you look at on your EAS, but we get those. And we parse those out and create a database. Here's another very old database, which doesn't have very much on it, but we keep up with IPAWS, people that received the required monthly tests and who received our tests from our 2 state relays. So we parse that out, feed it into a database, and create this so we can see how well our information is being distributed around the state. Now, break just a quick monitor right here about the things that are important in setting up this system is to create a committee, design some sort of redundant distribution system. And one thing that we have added, and we'll sort of try to close it out on this, the FCC, when they created the new state plan, which is an online state plan for your EAS plan, they ask that we have some sort of redundant reception source for a national level alert. The reason being, as I mentioned earlier, that the most states only have one primary entry point. And you can sort of know where I'm going with this. It's the old put all your eggs in one basket syndrome. If you have only one primary entry point, which is receiving messages from the White House or from FEMA, if that station is off the air when a national alert occurs or has some other technical problems, nobody in the entire state will get that alert. So the commission told all the committees that you need to come up with a method to receive a redundant PEP source. And my question on the conference call was, okay, we'll be happy to do that, but what are redundant sources? And they said there are 2 sources that you can use. One is the Sirius Radio Network, their channel 1, their barter channel, and National Public Radio's Squawk channel, or NPR 1. And they asked nicely, or sternly, I should say, that all the states install systems to act as a redundant receive source of national level alerts. So these 2 agencies operations, Sirius Radio and NPR, have direct connections via a VSAT system, just like all the PEP stations do, with FEMA in Washington. So they get those tests and alerts. So what we have done here in Alabama, we have all our NPR stations have wired their output of their Squawk channel into one of their inputs on their EAS devices. And we actually got a grant, and we bought 30-something Sirius radios and outside antennas. And we're in the process now of installing those. Not only we want to make sure that all our LP1s and LP2s have this Sirius radio installed, and then we have some extras that we can put at other key stations around the state. So I encourage you to check with your SECC and your state Emergency Communications Committee, and make sure that they are aware of that requirement and see what they're beginning to do on that. You can actually go and buy your own Sirius radio if you like and install it. And the way the radios actually work on Power Up, they come up to the barter channel 1. So you can wire that directly into your EAS device. One thing that you do have to do, and I'll make mention of this, and you might want to make a note of this, if you do your own, or if the state does it, they'll do it for you. But you have to create They do send a weekly test. That way you know that it's working. But to be able to monitor that weekly test correctly, you need to set up a second required weekly test filter in your EAS device, and it's set up just like a regular weekly test filter, with the exception of the area. Rather than being your local area, the counties in your local area, the area will be District of Columbia, because that's where it's actually transmitted from. So once you get your Sirius radio wired into your Sage unit, then make sure that you go and create another, in your incoming filter, create another required weekly test filter, set it up just like your regular one that you have in there, but change the area to be District of Columbia rather than the counties that you are serving. And that will give you some redundancy. Both of these systems, NPR and Sirius, feed weekly tests, and you can log that as another source. So that way, if your PEP station fails, or the distribution from the PEP station fails during a national alert, then you will have some sort of redundancy. The actual national alert, which has live audio, will not be fed on iPods. There's some confusion on that by around the country. Because iPods is tied into the government and they send national tests and all that. But if there's an actual alert from the White House, which has live audio, it will only be distributed through the primary entry point network of stations, and now through Sirius XM and NPR1. So this gives you a redundant source of receiving those. Now, hopefully, we don't want to have a national alert, but in case it happens, you want to have redundancy. It's just like you guys working at a radio or TV station. If you've only got one transmitter and it goes off the air, you're off the air. So redundancy is so important, not only in transmitters, but STLs or any other type of equipment. You need to have backups so you can stay on the air. Well, so do you need backups for your EAS as well. And now that they have that set up, that is a really, really big plus to have, especially for national alerts. Hopefully we'll never use it, but at least we've got that system there. The other thing that you need to do is make sure that you verify your station monitor assignments and make sure you're complying with what your state committee has assigned. They will have assignments, and as I said earlier, if you can't monitor a particular source, then they can assign you a different source. And so that's just sort of an overview of EAS. Hope that was sort of informative. If you have any questions about anything about EAS, about the monitoring system that we have, I encourage you to get a hold of me, and I'll be more than happy to talk to you about it and send you a copy of what we're actually doing and go through it and tell you how it operates. So we appreciate everybody joining us. We'll, like I say, our special guest, Mark Johnson, had some medical problems with his back and was not able to be with us, but he will be with us in another month. Our next meeting will not, that's the wrong slide, isn't it? August. Our next meeting will actually be in November, which will be November 21st, and we're working on a really good program for that particular date as well. Not August 15th, but November 21st. So with that, we'll end our webinar today. We appreciate everybody joining, and there's my email address if you have any questions about EAS and you can't get a hold of your SEC chairman. If you don't know who it is, you can contact your state broadcasters association and they can tell you who the chairman is. But if you can't find out who it is and you need questions answered about EAS, or you want to learn about our satellite distribution system or our monitor system, drop me an email at lwilkins@al-pa.com, and we'll be just tickled to death to help you with it. Thank everybody for joining us, and we'll see you next month.